Hello, welcome to my channel. In this video I'm going to quickly differentiate between rational and irrational numbers, but before I start, please, I would like it if you subscribe to this channel and like this video, and please feel free to comment if you have any questions, and you can also comment on the topics you would like for me to teach. So now, what are rational numbers? These are basically numbers that can be expressed in exact ratio or fraction. For example, we have ratio 1:3, 4:8, 6:7, for instance. Now all these are fractions, can also be expressed in fractions. Like this can be seen as 6/7, and this is 4/8, which can be broken down more, and this is 1/3. And all these are examples of rational numbers, but I'm going to quickly discuss the different categories of rational numbers. The first category of rational numbers are natural numbers, like 1, 2, 3, 4, 5, 6, and it goes on. Now all these are examples of rational numbers, and they are in the first category. The second category of rational numbers are fractions, like I said before. Like we have 1/2, 3/4, 19/17. Sorry, this line is too long, and so on and so forth. And the third category of rational numbers is recurring or repeating decimal numbers. What this means is that if, let's say, we have a fraction like 2/3, we have 2/3, for instance. 2/3 is equal to 0.6666, and it goes on. Now when we have recurring decimal numbers like this, they are known as rational numbers. And now let's move on to another category. Another category of rational numbers are the square roots of perfect squares. Now first of all, what are perfect squares? These are numbers that have their square roots as an integer. For example, 9. If we take the square root of 9, we are going to have 3. So 9 is a perfect square. Another example of a perfect square is 49. If we take the square root of 49, we are going to have 7. Same thing for 81. If we take the square root of this number, we're going to have 9. So 81 and 49 are perfect squares. The square root of perfect squares are rational numbers because they are also like the first category, which I discussed earlier. So the square root of perfect squares is another category of rational numbers. The square root of 49 is 7, and other examples still continues. There are plenty. Now the final category of rational numbers I would like to discuss is 0. Now some might say 0 is not a rational number, but in real sense it is a rational number because you can express 0 in exact ratio. Like we can have 0 ratio 4, for instance, which is the same thing as 0 over 4. And if you do this, we are simplify this, we are going to have 0. So since it can be expressed in ratio, whole ratio, meaning that 0 is a rational number. So now let's move on to irrational numbers. So now, what are irrational numbers? These are numbers that cannot be expressed in exact ratio. And I'm going to give you different categories of irrational numbers. The first category I would like to discuss is pi. Now, we know pi to be 3.1415, and it goes on and on and on and on and on. Pi is an irrational number since it cannot be expressed as a fraction or in whole ratio. Now, you might say that pi is also expressed as 22 over 7. So how come it's an irrational number? Well, you see, 22 over 7 is like an approximated form of pi. And since pi itself is not a fraction, therefore pi is an irrational number. I just want you to take note that 22 over 7 is the approximated form of pi. This means that pi on its own is not exactly 22 over 7, but 22 over 7 is the estimated version. Now, another category of irrational numbers I would like to discuss is non-recurring decimal factors. Like pi, we notice that the numbers are recurring, but it's not still a rational number because the numbers, it cannot be expressed as a fraction. Another example of irrational number, another category is when numbers have non-recurring decimal factors, and this can be seen in the square roots of non-perfect squares. For instance, we have the square root of 10. The square root of 10 won't give you an integer, but it will give you a decimal number which cannot be converted into a fraction, and therefore is not a rational number. Another, we have the square root of 17, the square root of 21, the square root of 30, and the list goes on. All these are examples of irrational number. And I also want you to note this third category of irrational numbers. Like I said, when decimals are non-repeating, like the decimal numbers are in constant change, they are not really stable. And like I said before, you can see this in these square roots of non-perfect squares. Like for instance, the square root of 10 is 3.16227, and it continues. So all these are examples of irrational numbers.